Mohan sir, shall I start? Sir, am I audible? Am I audible? Okay. Yes. Good afternoon, students. So, welcome you all to yet another session of PRERANA, the scheme for preparing SCSE students for higher education. So, I thank the management, the principal, and my HOD for giving this opportunity to present you about a few problems and the topics which will be covered under for the GATE exams under ECE for the subject communication. In that, I'll be taking the subtopic analog communication. Okay. So first, before going into the topic, let us see what is the type of questions which you'll get in the GATE ECE question paper. So here the distribution of marks will be 15% is of general aptitude, 13% marks is of engineering mathematics, and 72% is of core subject. Okay, and the general aptitude, it comprises of 10 questions and 55 questions are based on, so totally I've got 65 questions. In that, the general aptitude consists of 10 questions and remaining 55, it is based on engineering mathematics and core discipline topics. Okay, so from these 65 total questions, about 30 questions are 1 mark questions, while 35 were 2 marks, right? So this was the analysis of the previous year question paper. So approximately the value changes with a plus or minus 5%. Okay. So the type of the questions asked in the question paper, they also include multiple choice questions and multiple select questions. So multiple choice in the sense you'll be having 4 choices, you have to select any one, and in multiple select questions you'll be given, sorry, you have to have more than 2 choices. Okay. And the third type is the numerical answer type questions where you will have to fill in the answers. Okay, so it will be just like a fill in blanks. Okay? You have to give the answers on your own. You cannot choose or you cannot select. You have to give your answers on your own. Okay, so this is the percentage of the communication subject out of the entire 55 questions given in the ECE GATE syllabus, approximately 14. So it varies from 10 to 14% when we did an analysis with the previous year question papers. So for GATE 2021, the communication, it had a 14% coverage. That is totally, as you can see that out of all the subjects, this communication, it is having more number of questions. Okay, so do concentrate on communications more because it is occupying nearly 14% of the total questions. Okay, so this is about yeah, who's this? Who has joined now?
Bhuvana Varshini, ma'am.
Okay, Bhuvanavashini.
Yes, ma'am.
Okay, myself Geetha, right? So you are preparing for GATE exams?
Yes, ma'am.
Okay. So now this is the weightage of the marks given to the subject communication out of all the remaining subjects, and nearly 14% of the questions are covered under communications. Okay. Okay. So with this brief intro, we'll get into the subject. Okay. So today we'll see about the modulation. So I'll just give you a broader idea of modulation. Okay. Okay, we'll straight away go into amplitude modulation. Hope you know the basics of modulation. So modulation, so in the process of modulation, two waveforms are involved. One is the message signal and the other one is the carrier signal. Okay, so the message signal is usually of a low frequency signal, and carrier signal, it is a high frequency signal. I'll just adjust. Okay, so hope you are able to see this. So the modulation consists of two signals. One is the message signal, and which is a low frequency signal, and the carrier signal, which is a high frequency signal. Okay. So one by one, students are joining. I'll wait. Okay, so modulation, it consists of the message signal, which is a low frequency signal, and carrier signal, which is a high frequency signal. So main purpose of a communication system is to transmit messages from one place to another. Okay, so this is the main purpose of a communication system. So in a communication system, we have a transmitter, the basic modules, and we have a channel and a receiver. Okay, so these are the main blocks of a communication system. So now here, when the receiver and transmitter are nearby, when it is a very short distance, for example, if it is in a single room, then we need not amplify or we need not go for any modification or change in the signal. But when the receiver is at a far distance, okay, so our audio signal, it is not capable of traveling long distance, so we have to do some processing for this audio signal so that it can travel long distance. Not only audio signal, video signals also, right? So the audio and video signals, they have the capacity in the raw form to travel only short distance. If they have to travel long distance, we have to process those signals. So for that reason, we go for the process called as modulation. Okay, so here we understand that if the frequency is less, it travels less distance, and to make the signal travel more distance or a longer distance, okay, we have to increase the frequency or we have to make the frequency high. Should be made high. So this is done with the help of a carrier signal. So this is done with the help of a carrier signal. Okay, so here the message signal, which is of a low frequency, is now, I think now we are able to understand. So the message signal, which is of a low frequency, has to be converted into high frequency. For that, we get the support of the carrier signal. So these two signals are involved in the process of modulation. Okay, so the modulation is the process whereby the characteristics of the message signal or the characteristics of the carrier signal is changed according to the amplitude of the message signal. Okay, what do we mean by the characteristics? So for any signal, we have three characteristics. One is the amplitude, second is the frequency, or we can call as phase. Okay, so amplitude, frequency, and phase. Okay, so these three are the characteristics of the signal. Now in case, so these are the characteristics of a signal. Now in case, if we change the amplitude of the carrier signal in accordance to the amplitude of the message signal, it is called as amplitude modulation. I think you will be able to understand this better with this. Okay, so here we have got three characteristics: amplitude, frequency, and phase. Okay, so now let us see, this is the modulating signal and this is the carrier signal. The modulating signal has got an amplitude. So this is your amplitude. And it has got a frequency and it has got a phase. Similarly, carrier signal has also got an amplitude, it has got a frequency, and it has got a phase. Okay, now let us denote the amplitude of the message signal as Vm, frequency of the message signal as Fm, and phase of the message signal as phi m. Similarly, we can denote the amplitude of the carrier signal as Bc, frequency of the carrier signal as Fc, and phase of the carrier signal as phi c. Okay. Now here, if so, these are the two signals. This is the actual modulating signal, or this we can call it as the message signal. Okay, so the message signal's amplitude, that is, here we have to change the characteristics of the carrier signal. That is, either we can change the amplitude, frequency, or phase. So depending upon the type of the characteristics, the type of modulation differs. So if the amplitude is changed, then it is called as amplitude modulation. If the frequency is changed, it is called as frequency modulation. And if the phase is changed, it is called as phase modulation. Okay, so AM is amplitude modulation, FM is frequency modulation, and PM is phase modulation. Now, if when the amplitude of the carrier wave is changed according to the amplitude of the message signal or the modulating signal, then it is called as amplitude modulation. So this is the definition for amplitude modulation. If the amplitude of the carrier signal is changed according to the amplitude of the message signal. Similarly, if the frequency of the carrier signal is changed according to the amplitude of the message signal, okay, and it is called as frequency modulation. And if the phase of the carrier signal is changed according to the amplitude of the message signal, it is called as phase modulation. Now you have to note that here we have three different characteristics, and all these three different characteristics in a modulation, that is either in amplitude, frequency, or phase modulation, it changes only according to the amplitude of the message signal. So here we are not bothered about the frequency or phase of the message signal. So this you have to note. So this, I think this diagram will help you to remove the that is a doubt. Okay, just the amplitude of the modulating signal is alone is taken for consideration. So we are not bothered about the frequency or the phase. Okay, so amplitude modulation can be defined as amplitude of the carrier wave is changed in accordance to the instantaneous amplitude of the message signals. It's called as amplitude modulation. Okay. So I'll just have a recap. Sorry. Okay, so amplitude modulation, it is defined as a process in which the amplitude of the carrier wave is changed in accordance to the amplitude of the message signal. Okay, so I think this you'll be able to see this better. Okay. Yeah. So now here, so the carrier frequency and the phase remains unchanged. So this is the carrier and the phase of the message signal. It remains unchanged. And this type of amplitude modulated wave, in general, it is called as AM wave, or it is called as double sideband full carrier, DSB FC. So you will understand why it is called so when we go for the mathematical expression of this amplitude modulated wave. Okay, so the message signal has also got its own other names, that is modulating signal. It is also called as baseband signal, and this signal contains the information which is to be transmitted from the source to the destination. And the carrier signal, it is a high frequency signal, right? And it is an empty signal. It does not contain any information on its own. Its purpose is just to carry the message signal from source to destination. And usually this message signal, it will be of a low frequency, and this carrier signal, it will be of a high frequency. Now coming to the representation of the waveforms, how it will look like, right? So this is the message signal. Okay, so the message signal, you can see that it is having a amplitude of Vm, right? So plus Vm and minus Vm, and it is occupying a frequency Fm. So this is the time period. Time period is the time taken for the full cycle to complete, and that is called as the frequency. So time period, so this is the time period. 1 by time period, it will be the frequency. So we can write time period equal to 1 by Fm. Okay. Now next, this is your carrier signal. You can see that the carrier signal in comparison with the message signal has got a higher frequency, right? Because this is going to carry the message signal, and also it has got an amplitude greater than that of the message signal. The relation between the amplitude of the carrier signal and the amplitude of the message signal, so those things we'll see in the coming sessions. Okay, so next, this is your, so here you can see that, so this is the time period for one cycle. You can see that the time period is very less, which means that the frequency is more, right? So within a time t, you'll be having more number of cycles generated. So that is what we mean by high frequency. Now this is your modulated signal. Okay, amplitude modulated signal. You can see that the envelope of the amplitude modulated signal is same as that of the message signal. Okay, so if you just see this signal, right, so it is just like that of the message signal, and inside you have got the carrier signal. So we can say that this modulated signal is having the envelope of that of the message signal, and it is having a frequency as that of the carrier signal. So Iniko, okay, so now let us see the mathematical expression of the amplitude modulated wave. Okay, so the modulating signal is represented as Vm of t, and that is taken as Vm cos omega m of t. So Vm is the amplitude and omega m is the frequency of the message signal. So Vm, it is the amplitude of the modulating signal or the message signal, and omega m, it is the frequency of the message signal. And carrier signal is represented as Vc of t. Okay, so which is Vc cos omega ct, right? And Vc is the amplitude of the carrier signal, and omega c, it is the frequency of the carrier signal. Okay, and now the modulated wave Vam of t can be written as Vam cos omega ct. So Vam, it is the amplitude of the modulated signal. So note the difference between modulating signal and modulated signal. Okay, so here the amplitude of the modulated signal can be given as Vc plus Vm of t. So I hope you remember this diagram. You can understand from this. So here this is your modulated signal, so which we call it as Vam. Okay, so this is Vam of t, and this is Vc of t, and this is Vm of t. So Vam of t, it can be written as, so this is your Vc plus Vm of t. So to the amplitude of the carrier signal, I am adding the message signal as such. So we get the expression Vam is equal to Vc plus Vm of t. So which can be written as Vc plus Vm cos omega m t. Okay. So Vm of t is Vm cos omega m of t. So we can take this Vc common outside. So it can be written as 1 plus Vm by Vc cos omega m of t, which can be written as 1 plus Ma into cos omega m of t, where Ma is equal to Vm by Vc. So where Ma is the modulation index. Okay, so this is about the amplitude of the modulated wave. Now we have to get the expression for the modulated wave. So modulated wave is VAM of t. So VAM of t, it is given by VAM of t is the amplitude modulated wave. It is given as VAM into cos omega c of t. So already we have got the expression for VAM of t. So it is Vc into 1 plus Ma cos omega mt into cos omega ct. So now we are multiplying this with each and every variable. So we get Vc cos omega ct plus Vc into Ma cos omega m of t cos omega ct. So using the trigonometric ratio, we just expand this and we get the expression as VAM of t equal to Vc cos omega ct plus Ma in MAVC by 2 into cos omega c minus cos omega m of t, which is your lower side band, plus MAVC by 2 into cos omega c plus omega m of t, which is your upper side band. Okay. So now here, so from this expression VAM of t, we can see how it is used to represent the spectrum. Okay, so Vc cos omega ct, it is your carrier wave, and plus Ma Vc by 2 into cos omega c minus omega m of t is called the LSB, and Ma Vc by 2 into cos omega c plus omega m of t is called your upper sideband. So we can represent this. This is the spectral representation or the spectrum of AM wave, where you have got the carrier wave at the center Vc, which is a frequency of omega c, and you have got another component lower sideband, which is to the right of which is to the left of the carrier signal, that is with an amplitude Ma Vc by 2 and having a frequency of omega c minus omega m, and to the right we have the upper sideband, which is Ma Vc by 2, which is having the frequency omega c plus omega m. Now when we calculate the bandwidth, so the bandwidth is calculated as upper cutoff frequency minus lower cutoff frequency, which is equal to omega c plus omega m minus omega c minus omega m, which will be equal to 2 omega m. So the bandwidth is given as 2 omega m. Next, let us see the phasor representation of the amplitude modulated wave. So it is given as VAM of t equal to Vc cos omega ct. So already we know this expression. Now how to represent them in phasor? So this is your carrier wave. Okay. So carrier wave is represented as Vc of t, right? And upper sideband, it is from a, that is it is a at a frequency greater than omega m from omega c. So this is your upper sideband with an amplitude Ma Vc by 2, and this is the lower sideband, which is of a frequency omega m omega c minus omega m. So it is in this direction, so lower sideband. So we take the resultant of these two vectors, which will be using the parallelogram rule. So this is the resultant of the upper sideband and lower sideband, right? So upper sideband and lower sideband, we know the parallelogram law of addition. Using the addition, we get the upper sideband plus lower sideband. So this carrier wave plus your upper plus and lower sideband becomes your AM wave. That is your double sideband with full carrier. So double sideband with full carrier. Okay, so next let us see about the modulation index and the percentage of modulation. So the modulation index and the percentage modulation. So the amount of amplitude change in the modulated carrier signal from its unmodulated level with respect to the amplitude of the message signal after modulation is called as modulation index, which is given by the ratio Vm by Vc, where Vm is the amplitude of the message signal and Vc is the amplitude of the carrier signal. So usually the modulation index, it lies between the value 0 and 1, right? And if and for a good modulation, Vc should be greater than Vm. That is, the amplitude of the carrier wave should be greater than Vm. So I hope now you understand why we had a waveform like this. So if you just revisit this waveform, you can see that the carrier signal is having a greater amplitude compared to that of message signal. So modulation index is the value should be it should lie between 0 and 1 for proper modulation. So Vc is always greater than Vm. Just a second. Why we should have the carrier wave greater than the message signal. So when the message signal and the carrier signal, if they are of the same amplitude, then we say that we achieve 100% modulation. Okay. So depending upon the value of the modulation index, or depending upon the amplitude of the carrier wave and the message signal, we have three types of modulation that we'll be seeing later. Okay. And the percentage modulation now can be calculated as Vm by Vc into 100. So mostly you will get problems in this modulation index. So just make a careful note of this. Now let us see how to calculate the modulation index from the amplitude modulated wave. Okay, so this is I've drawn all the three waves in a single graph, right? So this is your amplitude modulated wave, right? And this is your carrier signal. Okay, and here your envelope is your message signal. Okay, so now you can see that. So here we have taken the carrier wave amplitude greater than the message signal. Okay, so here, so this is Pm and here this is Vm. So this total length, it is taken as 2 Vm, right? And for the amplitude modulated wave, the maximum value is taken as Vmax and the minimum, so this is your minimum value, Okay, so here this is taken as Vmax, okay, and this is taken as Vmin, minimum. Okay, and Vmax, now we can understand from this diagram that Vmax is equal to, so this is your carrier wave, okay, carrier amplitude, that is Vc, plus your Vm. Okay, so Vc plus Vm is your Vmax. Now coming to Vmin, Vmin can be taken as Vc minus Vm. Okay, so Vmin can be written as Vc minus Vm. Okay, so we get Vmax is equal to Vm plus Vc, and Vmin is equal to Vc minus Vm. Vmax minus Vmin will be equal to Vm plus Vc minus Vc minus Vm, which is equal to 2Vm. So we can similarly, if we add these two, we get Vmax plus V minimum equal to 2Vc. So we can write, we know that the modulation index is MA is Vm by Vc. So when we subtract Vmax and Vmin, we get 2Vm. And when we add Vmax and Vmin, we get 2Vc. So we can write Vm is equal to Vmax minus Vmin by 2. Vc equal to Vmax plus Vmin by 2. So modulation index can be written as Vm by Vc equal to Vmax minus Vmin divided by Vmax plus Vmin. So the modulation index is, so this is your the expression for modulation index. So now when you are given the values of the amplitude modulated wave, where we know the Vmax and Vmin values, then we'll use this formula for calculating the modulation index. And in case if we know the amplitude of the message signal and the amplitude of the carrier signal, we'll be using this formula to calculate the modulation index. So now let us discuss about the three types of modulation. Okay. Types of modulation. The first one is over modulation. Second is critical modulation. And the third one is under modulation. Okay. So this is your message signal. This is the carrier signal. Now when you just compare, see the message signal and carrier signal, you can see that the carrier signal's amplitude is less compared to that of the message signal. Okay. So now when we have the message signal amplitude greater than the carrier signal, or if the amplitude of the carrier signal is less than that of the message signal, we get this over modulation. Okay. So when the message and signal of this type is modulated, then we get the amplitude modulated wave like this. Okay, where we can see that the envelope value is lost. So this is the actual envelope, but because of this overlapping, we lose the information. So here this is called as the distortion. At this point, we lose the information about the message signal. So it is very difficult to recover back the message signal by the process of demodulation. Okay, so this distortion happens when the modulation index is greater than 1. So as I told you before, the desirable value of modulation index is between 0 and 1. This is about over modulation. Next is about critical modulation, the second type. So critical modulation, here you can see that the message signal's amplitude and the carrier signal's amplitude both are same. The message signal's amplitude as well as the carrier signal's amplitude both are same. Okay, so in that case, you can see that it is exactly touching at this point and we are not losing any information. Whereas in the case of the previous one, that is over modulation, this came below and we lost the information here, which led to the distortion at this point. Here exactly it touches, so we are able to recover back the message signal when we demodulate the signal. Okay, so this is called as critical modulation. So next is under modulation. Under modulation is the case which we saw before, that is at the beginning as the amplitude modulator wave, right? So we have got the message signal and the carrier wave is greater than the amplitude of the message signal. So in that case, we'll be getting the amplitude modulated wave like this, where, so this is the envelope is the message signal and we can recover the message signal back by the process of demodulation. Okay, so I think now the people would have got a broader idea about the amplitude modulation, that is the double sideband suppressed, double sideband full carrier. Okay, so now that the time is 3:30, we'll have a break and we'll join after 10 minutes. We'll join by 3:40. We'll do some problems after this, after the break.